No worries.
Okay, now is it recording? Yes, it is.
Yes.
Okay, so if I say that instead of using word proportion, I use probability. I use the word probability. So in that case, if I say that if I select two students from this class and those two are male students, so what is the probability of selecting two male students? In that case, you will say that there are two male students and we are selecting wait, I put it in this way that we say that we select one male student. We select one male student. So in that case, we will say that we are selecting 2 by, because there are two male students, so we will select 2 by 8. Is that clear?
Yeah.
Yes.
Okay. So similarly, if I say that I select one female student from this class, what is its probability? In that case, we will say that its probability is 6 by 8. Its probability is 6 by 8. Understand?
Yes.
Okay. Now, this is one concept. Now I explain another concept, which is, for example, if I say there are two male students, B1, B2, boy1, boy2, boy3, girl1, girl2, girl3, girl4, let's say, and girl5. There are 8 total students. And my internet connection was bad. Can you let me in the class? Park, you are not in the class?
We are in class.
Or admit. Okay. So B1, B2, B3, G1, G2, G3, G4, and G5. Now I say that I select one boy. I say I select one boy. The probability of selecting boy will be
1 by 8.
huh?
1 by 8.
Not 1 by 8. I am selecting one boy, but there are 3 boys. So it's
3
probably
by 8.
3 by 8. Understand? Because there are 3.
You mean boy? You mean?
Mhm.
Oh, okay.
Is that clear?
Yeah.
If I say that I want to select one girl, if I say that I want to select one girl, in that case, what would be the probability of selecting girl?
5 by 8.
5 by 8.
5 by 8. Now, do you think why it is 3 by 8 and why it is 5 by 8? Who can answer me this? Crystal.
Because out of 8 options, you only have 3 chance to select the boy, which is 3 by 8.
Very good. Very good. Is that clear to everybody?
Yeah.
Yeah.
For example, if I say there are 3 boys, I want to select one boy. I can select this one, I have, this is my first option. I can select the second one. This is my second option. I can select the third one. This is my third option. So in total, there are 3 options out of 8. So it means that its probability is 3 by 8. So there are 3 possible ways I can select one boy out of 8 students. Similarly, when we say that select one girl, I can select either this one, this is first option, either I can select this one, this is second option, either I can select this one, this is third option, likewise this is the fourth option, this is the fifth option. So I have 5 options in total. Is that clear?
Yes.
Okay. And similarly, one more thing, one more thing is that why it is 8 in denominator. Why there is 8 in the denominator? Because there are 8 options. There are 8 options: B1, B2, B3, G1, G2, G3, G4, G5. So either I can select first student, either I can select second student, either I can select third student, fourth, fifth, sixth, seventh, and eighth. So there are total 8 options. So that is why it is divided by total number of options. Total number of options to select a boy divided by total number of options that I can select a student. Try to understand the difference. First, we are saying select a boy. We are selecting a boy out of 8 students, out of 8 people. So that is why it is 3 and it is 8. Is that clear to everybody?
Yeah.
Okay.
Yes.
Now twist is here. Same question. I say that B1, B2, B3, girl 1, girl 2, girl 3, girl 4, and girl 5. Now I say that I want to select 2 male students. I want to select 2 male students. And I must say one more thing. What I am explaining, it is very, very important from exam point of view. And you can never understand probability in such a simple way, in such a easy way. Understand? So if you don't follow, if you don't understand anything, please make me stop at the spot so that I can explain it in a more detail. Understand? So now my question is, again, there are 8 students in total. I am saying that we want to select 2 boys. We want to select 2 boys out of 8 students. Now, what would be the probability? Now, what would be the probability? Crystal?
How to say? Oh, oops.
Uh-huh. Who can answer me? What would be the probability? Jackie? Jackie, Park?
I cannot see. It's black. I have a black screen.
Why?
Wait, I don't know. I don't know,
Everybody can
sir.
see my screen? Please let me know.
Yeah.
Now I can. Now I can.
Everyone can see.
Jackie, you made a wonderful excuse. I have no argument to make.
Sir, how can I make excuse?
Okay, Crystal.
I'm just guessing. 3
Okay.
by 8. 3 by 8.
No. See, now I am selecting 2 students. Count.
2 by 8.
No, count number of options.
2 by 3.
Let's see. I can select
2 by 3.
2 students. This is my first option. Understand?
Yeah.
I can select these 2 students. This is my second option. Understand? I can select these 2 students. This is my third option. Is that clear?
Yeah.
Yes.
So total number of options,
Are 9.
Is 3.
3. Total number of options that I can select 2 boys
3.
are 3. Now, out of how many students? Out of 8 students. Out of 8 students. So now here is the difference. Here is the twist once again. Now, how many options that I can select 3 students? I'm not talking about now boys. I'm not talking about boys. Now I am talking about that how many options are there that I can select 2 students. Let's see. I can select these 2 students. This is my first option. I can select these 2 students. This is my second option. I can select these 2 students. Third option. This is fourth option. This is fifth option. This is sixth option. This is seventh option. This is eighth option. 9, 10, 11, 12, 13, 14, 15, 16,
18.
17,
Is that a power roll?
18, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, and 28. There are 8 options that I can select students. So the probability is 3 over 28. Understand?
Oh,
Yeah.
Is that clear?
Yeah.
Yes.
Okay.
But how, yeah, how can you calculate it faster than doing that?
Dangisha,
Or you,
Dangisha. Okay.
okay.
Now let's say we have B1, B2, B3, G1, G2, G3, G4, and G5. Now I say that I want to select 3 girls. I want to select 3 girls. In that case, again, we will say that I can select either these 2 girls, either these 2, either these 2, either these 2. Is that clear? The question,
Yes.
the question is, what is the probability to select 2 girls? Now, how many options? Number 1,
10.
2, number 3, number 4, 5, 6, 7, 8, 9, and 10. Who said 10?
Me, Chandra.
Chandra. Very good. So the total number of options. So the total number of options to select 2 girls is 8, and again out of 8 students, we are selecting 2 girls, so the total number of options are 28 like we calculated before. So the probability will be 8 by 28. Understand?
No.
Yes, ask me questions.
Well, where did the 8 come from?
8.
Yes.
See, there are 5 girls. There are 5 girls, G1, G2, G3, G4, G5. I want to select 2 girls. How many options are there? I can select 2 girls. I can select any 2 girls. So the first condition is I can select
2 to the power of
these 2.
3.
Hmm?
2 to the power of 3.
No, not 2 to the power 3.
No, why is that like that? So how did 28 come from? Like how did that? Is it from the same as last one?
Yeah, it is same like the last one, but there is a quick way like Carolina was asking me. Now,
Yes.
this is a simple way, but when you have a big problem, for example, when you have more than, if you need to select more than 2 or 3 students or more than 2 or 3 or 4 numbers, in that case, we use a formula which is called combination. I don't know, did we study it in fundamental mathematics or not? Combination. Did we? Huh? Combination. The combination says that if n is total number of objects and R is the number we are selecting out of n numbers, then who is this? Please mute your microphone. Then total number of options are NCR. This is called combination. NCR, which is n factorial divided by r factorial and n minus r factorial. This is a function in your calculators. You can see it in your calculator. Maybe it would be in my computer's calculator. I'm not sure. Factorial, NCR, factorial I have, but NCR, scientific. This is scientific. And the programmer, what is programmer? Well, I don't have NCR function in my calculator, my computer's calculator, but for sure in your calculators you will have a function NCR. Understand? You can
Yes.
use that function and you can calculate the result. For example, we were saying that we were selecting 1 boy out of 3. There were 3 boys in the class, so n was 3, and we were selecting 1 boy, so r was 1. So 3C1, if you solve it in your calculator, it would be 3. You can get total number of options. Similarly, there were 8 students. And we were selecting 2. So it will be 8 factorial over 2 factorial, 8 minus 6 factorial, which would be 8 times 7 times 6, 8 times 2. over 2 factorial times 6 factorial. So total number of options are 28. This is how we solve the factorial. I don't want to get into this, that how do we solve the factorials, because it is very simple in your calculators. You can simply use your calculators and you can solve it in your calculators. Is that clear? So you see, if you use your calculator, you can directly get 8C2 is 28. You don't need to do all this calculation. You don't need to do all this calculation to get 28 options. Is that clear?
Yes.
Yeah.
Okay, very good. Now we take another example. We say that there is a class. In that class, there are 10 boys and 8 girls. Total are 18. We find the probability. Find the probability to 5 students that are male or boy. We're using word boy, so we say select 5 students that are boy. Understand? So we call it event. We call it event in the terms of, in probability term, we call it event. So we define it. Let E is an event that we are selecting 5 boys. Understand? So total number of options to select 5 boys. We denote n denotes number of events, that how many events or how many options in that event, we denote it by n of e. Now I am going towards the formal definition of probability. This is how we normally solve the problem. Understand? So n of e, there are 10 boys. Out of 10, we are selecting how many? 5. So it is 10C5. This is total number of options. And there is another definition which is called sample space. Which is called sample space, means total number of options. Total number of options. There are 18 students, and out of 18, in total we can see there are 18 students, and out of 18 we are selecting 5. So it is 18C5. In that case, the probability of event, what is our event? Our event is to select 5 students. Is total number of ways to select 5 students divided by total number of ways to select 5 students out of 18. Understand? Is that clear? Any question? Any question? No question? Okay. So you can solve it in your calculators. 10C5. What is 10C5?
252.
252 over 18C5.
8568.
3. So that is your probability. You can divide them and you can get the probability.
No, 8568.
5, 6, 0. Is that clear?
Yeah.
How do I enter into the calculator?
Huh?
How do I enter this value into the calculator?
There is a function called NCR. You can see it would be written like NCR. Either it will be on a button or top of the button, like here. Between two buttons. Maybe it could be on a button, like for example, this is your calculator button. Maybe it could be written here, or if like in your calculator we have 1, 2, 3, 4. Maybe it would be written somewhere here between two buttons. Understand? So you can use that function in your calculators and you can easily get the answer.
Okay.
So sample, in this particular example, I introduced two more examples, two more. One is event and the second one is sample space. Sample space, we call this word sample space means that the total number of options. Okay, so next is, we say that we use another definition, fundamental principle of counting. Fundamental principle of counting. For example, here we are using this word that I select 2 boys, I select 3 girls. We, in terms of probability, in the language of probability, we say that we are performing experiment. We are performing experiment. Understand? So in that case, fundamental principle of counting says that if you perform two experiments. Two experiment means to say that I select 2 girls and 2 boys. Two experiments means to say that we select 2 boys and 2 girls. Now these are 2 different independent experiments. To select number of boys will not affect any way selecting number of girls, and similarly to select number of girls will not affect in any way to select number of boys. I cannot say that if I select one boy, the other one will be girl. No, they are totally independent. They are not depending upon each other. So when you perform two experiments, independent experiments, then total number of outcomes of the first experiment, total number of outcomes of the first experiment times total number of outcomes of the second experiment will give us total number of outcomes. I give you a simple example. It is exactly like this. If I say that you toss a coin, how many options do you have? How many possibilities that you can get? How many numbers if you toss a coin? you can get either head or tail. Understand?
Yeah.
If you toss a coin, you can either get head or tail, followed by, after tossing a coin, you roll a die. You roll a die. Now these are two independent experiments. So the total number of outcomes will be the total number of outcomes of the first experiment times total number of outcomes of the second experiment. For example, if I toss a die, either I can get head or tail. Followed by, I am rolling a die. I can get either 1, I can get either 2, 3, 4, 5. Head 1, head 2, head 3, head 4, head 5, and head 6. Similarly, maybe you can get first tail, then you get 1, tail 1, tail 2, tail 3, tail 4, tail 5, and tail 6. So total number of options are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the total number of options are 12. That is why we say that when we perform two independent experiments, total number of outcomes of the first experiment times total number of outcomes of the second experiment. Now, after studying this fundamental principle of counting, we come back to our regular example. What is that? Again, coming back to this example, let's say we have B1, B2, B3, girl 1, girl 2, girl 3, girl 4, and girl 5. Now the question is what is going on? What is the probability to select two boys and two girls? Understand? Any question? Say yes or no if you have any question, please.
Not yet.
So the question is, what is going on? Okay. What is the probability to select two boys and two girls? We say that boys are 1, 2, 3. There are 3 boys. Girls are 1, 2, 3, 4, 5. Total are 8. How many we want to select? 2 girls and 2 boys. We want to draw 4. Understand? So the sample space would be what's the
Wait,
possibility?
who is?
Uh-huh.
Oh, sorry. Did you write this one? What's the possibilities? What are the events? Did you write this one?
No, I did not write this.
Wait, someone is writing or like drawing something on here on the board. Can you please
Oh, I
stop?
thought that's notes because it says annotate. Oh,
Yeah,
I
but
thought
everyone-
only I
yeah,
can see it.
everyone is like looking at it, and I was so confused.
Who can?
Uh,
Yeah, you better
I-
delete it. Yeah,
I'll
because
deal-
it's just
I
delete
thought it
them.
was notes.
No, everyone
You
can see
can,
this.
you probably can delete it if that's the case. I don't know how
Who
this
can
happens.
So I mean, I cannot.
I mean, can you write on this?
Yeah, like
Yeah,
some.
I just found out. Okay,
So
not
you
okay. Excuse me. All right.
It's
no,
fine. It's fine.
I mean, who was writing this? Who was writing this?
Tiffany, Mary. Tiffany.
Okay, please don't write then.
Okay.
That you can. How can you write? This is my computer. I'm.
It's under view option,
Anybody
and
else?
then there's
Write?
Yeah, we can all write.
Okay, then please don't write. So sample space is how many total people? There are 8 people, and how many we are selecting? We are selecting 4. 8C4. Carolina, what is 8C4?
I haven't found it on the calculator yet,
Okay, then just calculate it.
but I haven't found the function.
Then who was telling me before?
you can click NCR twice. You can click it twice. Sometimes it comes up.
Anyways, whatever the result, you can put it here, 8C4. Now, we say that let E1 is the event to select 2 boys, and let E2 is the event to select 2 girls. Okay, so E1, how many boys? Out of 3 boys we will select 2, so it is 3, and n of E2, out of 5 girls we are selecting 2, so it is 10. I know it is 10. You can solve it in your calculators. So 5C2 is 10. Okay. So according to the fundamental principle of counting, the probability of finding E, the total number of outcomes of the first experiment, 3C2, times the total number of outcomes of the second experiment over total number of outcomes, total number of possibilities, 8C4. Is that clear? We are multiplying total number of outcomes of the first experiment with the total number of outcomes of the second experiment. Like 2 boys are coming from 3 boys, 2 girls are coming from 5 girls, and in total 4 students are coming out of total 8 students. Is that clear? Does it make sense? Please let me know. Please tell me, is that clear?
Yeah, it's clear.
Yeah.
Now we jump into the formal definitions and probability. Random experiment. The term experiment means a planned activity or a process whose results yield a set of data. A single performance of an experiment is called a trial. The result obtained from an experiment or a trial is called an outcome. If you have noticed, I was using the word outcomes, total number of outcomes. And all this was an experiment to select a girl, to select a boy. This is called an experiment. So random experiments have 3 properties. These were all random experiments. The experiment can be repeated practically or theoretically any number of times. Like we can select any number of students any number of times. The second, the experiment always has 2 or more possible outcomes. An experiment that has only one possible outcome is not a random experiment. Like in this particular examples, if you select 2 students, if you select one student, it could be either girl, it could be either boy. If you say that I am selecting 2 boys, then of course you will have more than 2 options. So the condition third is the outcome of each repetition is unpredictable. You cannot predict. For example, if I say select one girl, you are not sure that you're going to choose G1, G2, G3, or for example, if I take an example of your class, if I say I will select randomly one girl, I'm not sure that it would be Tiffany or Crystal or Carolina or Chandra or Ichaim or whoever. Understand? So These are the three properties of random experiment or random variable. Then sample space. We have used the word sample space in our example. Sample space means total number of outcomes. That what are the total possibilities? If I say that I want to select 3 students out of 8 students, so to select 3 students, I have many options. And what are those options? What are total number of options? We can figure it out by 8C3. Similarly, this is called sample space, a set consisting of all possible outcomes that can result from a random experiment is defined to be a sample space for the experiment and is denoted by a letter S. Each possible outcome is a member of sample space and is called a sample point in that space. For example, the sample space for tossing 2 coins once, if you toss 2 coins once, either you can get head on both coins, either you can get head on the first, tail on the second, or you can get tail on the first and head on the second, or you can get tail on both coins. Is that clear? Does it make sense? This?
Yeah.
Okay.
Yes.
Then another very important example and definition, which is called like events. As I said, all these experiments are called events. An event is an individual outcome or any number of outcomes. For example, there were 8 students in total, 3 boys and 5 girls. So the event in which we were interested in boys. We were saying that we select 1 boy, or we were saying we select 2 boys. This is called event. In a set terminology, any subset of a sample space S of the experiment is called an event. If somebody is familiar with the sets algebra, he will be familiar with this subsets, with this notation, with this subset. What does it mean? So if you don't know, no problem. Then from probability point of view, another very important definition is mutually exclusive events. 2 events A and B of a single experiment are said to be mutually exclusive or disjoint if and only if they cannot both occur at the same time. That is, they have no points in common. For instance, when we toss a coin, we get either a head or tail, but not both. The 2 events, head and tail, are therefore mutually exclusive. When a die is rolled, the outcomes are mutually exclusive as we get one and only one of the 6 possible outcomes. Either we can get 1, 2, 3, or 5, 6, or whatever. Either a boy or a girl. It is from this boy and girl we came to know that the examples which we were solving right now, all these examples were mutually exclusive events. What does it mean? For example, if I am saying I will select a boy, it does not mean that if I select one student and I can select boy and girl at the same time. Understand? So it would be either girl or boy. So they cannot occur together. So these 2 were mutually exclusive events. Is that clear?
Yep.
Okay. Then another definition is not mutually exclusive. If the 2 events can occur at the same time, they are not mutually exclusive. For example, if you are familiar with cards, if we draw a card from an ordinary deck of 52 playing cards, it can be both a king or a diamond. Understand? If we draw a card from an ordinary deck of 52 playing cards, it can be both king and a diamond. Therefore, kings and diamonds are not mutually exclusive. Similarly, inflation and recession are not mutually exclusive events. Is that clear? Not mutually exclusive events, those which can occur together.
I have another question.
Mhm.
What does the C in NCR stand for?
This is called combination.
Oh, okay. Oh,
This is called combination. Okay. Probability. A die is rolled. Let us define event E1 as the set of possible outcomes where the number on a face of the die is even, and event 2 E2 as the set of possible outcomes where the number on the face of the die is odd. Are event E1 and E2 mutually exclusive? We first list the elements E1 and E2. E1 is saying the die will show even numbers. So here we have all even numbers. Event 2 is saying that die shows only odd numbers. So 1, 3, 5 is odd. So is there any point in common between E1 and E2? Is there?
No.
This is called intersection. Mathematically, we call it intersection, which means that points in common. There is no point in common, so we say that it is empty set phi. So we first list the elements E1 and E2. So there is no point in common, so they cannot occur together. Similarly, example 2 is a very good example. When you will compare both examples, things will be more clear that what is mutually exclusive and not mutually exclusive. A die is rolled. Event E1 is the set of possible outcomes where the number on the face of the die is even, and event E2 as the set of possible outcomes where the number on the face of the die is greater than 3. Now, are event E1 and E2 mutually exclusive? Now you can see that E1 containing 2, 4, 6 even numbers, and event E2 number greater than 3, 4, 5, 6. Now, is there any point in common between E1 and E2?
4 and 6.
4 and 6. So they can occur together. 4 and 6 can occur together. They satisfies both properties. 4 is greater than 3. 4 is an even number. Similarly, 6 is greater than 3 and 6 is an even number. So they can occur together. They satisfy the both properties which were demanding, which were asked, like the number should be even or it should be greater than 3. Is that clear?
Yeah.
Are you familiar with cards? Are you guys familiar with cards?
Like
Yeah, kind of.
Yes.
Anyone who
cards?
is not, I can explain, otherwise we can jump into the next
Oh,
example.
cars. Mm.
No, I don't
You are
understand.
familiar with cards?
I'm not.
Who are you?
Jackie.
Come on, Jackie.
What's beside jokers?
Are you
There's 2 jokers.
are
And
you
then where's the other 2?
are you living in 21st century, Jackie?
My body, not my soul.
Tiffany, jokers are not in the deck of 52 playing cards. There are playing cards. There are 13 red and 13 black. Oh, sorry, 26. Where it is? There were 26 red and 26 black. Total are 52. Understand?
Yeah.
Now 13 king, not king. There were 13 hearts, 13 diamond, 13 spade, and 13 club. Understand? 13 heart, 13 diamond, 13 spade, and 13 club, and total are 52. Understand? Is that clear?
Yes.
Jackie.
Yes.
Yeah.
Now there are 12 picture cards, 12 picture cards, 4 for king, 4 for queen, and 4 for jack, and 4 are aces. Understand? Now
Yes.
jump into the PPT. A card is drawn from a deck of 52 playing cards. Event E1 to E5 are defined as follows: getting an 8, getting a king, getting a face card. Face card means picture card. Getting an ace, getting a heart. Now are event E1 and E2 mutually exclusive? Are event E1 and E2 are mutually exclusive? Who can tell me? One by one, I will ask everybody. Let me see in the participant. Okay, the number one, Tiffany, you are at top. Tell me, E1 and E2 are mutually exclusive or not?
The only reason I'm at top is because
Huh?
I
Yes, Tiffany.
okay, I have to answer. Okay, I don't know.
Okay, you don't know. Then who is this Khawani?
Yeah, this is Chandra, but I am not sure about the answer. I'm confused with the
Krista.
card.
They cannot exist at the same time, so it's no.
Yes, so it is mutually exclusive. They cannot occur together. Either you will get 8 or you will get king. You cannot get together both. So they are mutually exclusive. They are mutually exclusive. Understand? Number
So what
2.
does getting an 8 mean?
Sorry?
What does this 8 mean? Getting an 8. I don't really understand what they mean. Getting an
Means
8.
that it,
Is it just a number?
yeah, in cards you have start from aces. There are 4 cards for aces. Then there's a card with number 2, 4 cards with number 2, 4 cards with number 4, and 4 cards with number 4, 4 cards with number 5, 4 cards with number 6, 4 cards with number 7, 4 cards with number 8, 4 cards with number 9, 4 cards with number 10. Then it comes Jack, 4 cards with Jack, 4 cards with Queen, and 4 cards with King. All these are 52 playing cards. Getting an 8 means
Oh, okay.
we are getting this 8. There are 4 cards with number 8. We are getting 1 out of them. That is what it means getting an 8. Is that clear?
Yeah. Okay.
Okay. So getting an 8, getting a king, you will get a king or a 8. You cannot get them together in one card. So E2 and E3, getting a king and a face card. Now this is not mutually exclusive. You can get both properties in one card. If you get a king, it is a face card as well, because we have face on that card with king. Understand? So in
So,
that case,
sorry, face card is Joker and Queen too. So 3 different. Or
exactly.
oh, okay, okay, okay.
So in
Got
total, there are 12 face cards. You can see that. I wrote somewhere. Face card are so-called picture cards with picture. 4 for king, 4 for queen, and 4 for jack. Is that clear? Now, event E3 and E4. E3 and E4, face card and getting an ace. Now, this is mutually exclusive. They cannot occur together in any way. Now, event E5 and E1, getting a heart, getting an 8. Who can tell me this? Getting a heart and getting an 8.
Yeah, that's possible.
That is possible. Very good. So it is not mutually exclusive, because you can get a heart with 8. So here is the answer. E1 and E2 are mutually exclusive because there are number cards with an 8 and a king together. So there are no cards with an 8 and a king together. E2 and E5 are not mutually exclusive because a king is a face card as well. E3 and E4 are mutually exclusive because an ace is not a face card. E4 and E5 are not mutually exclusive because there is one card that has an ace and a heart. Similarly, E5 and E1 are not mutually exclusive because there is one card that is an 8 of heart. Is that clear? How about how?
Yes, it's okay.
Do we have to know about this whole card process? I have never really seen this
It is very
card.
important, Chandra. It is very important. You
Oh,
must,
it is.
yeah, soon after the class,
Oh.
you must buy a deck of playing cards and just
Mhm.
learn it that what is what. You can play a simple game with your friends. Yeah, it will be really beneficial for you.
Okay.
Hmm.
Okay.
2 dice are rolled. We define events E1, E2, E3, and E4 as follows. E1 getting a sum equals to 10, E2 getting a double, E3 getting a sum less than 4, and E4 getting a sum less to 8. Are events E1 and E2 mutually exclusive? Are events E2 and E3 mutually exclusive? E3 and E4 and E4 and E1. E1 and E2. E1 is getting a sum equals to 10 and E2 getting a double. Is that mutually exclusive or not?
What is a double?
Double means, for example, you roll a pair of die. Understand?
No.
5 can equal to 10.
Yeah, getting a sum equals to 10. Maybe you get 6 on the first die, 4 on the second die. Maybe you get 5 on the first die, 5 on the second die. Maybe you get 4 on the first die and 6 on the second die. So these are the 3 options. When you roll a pair of dice, the sum is 10. Getting a double. Here you are getting a double. Now this number 5 contains both properties. The sum is 10 and we are getting a double. Same number on both dice. Is that clear?
Yes.
Okay. E2 and E3. Getting a double, getting a sum less than 4. Getting a sum less than 4. Less than 4 means 2 and 1, 3, 1 and 2, 1 and 1. Now again you are getting a double and its sum is less than 4. So it is not mutually exclusive. Are you getting my point? Is that clear? Please tell me.
Yes.
Okay. So here you can see that E1 and E2 are not mutually exclusive because outcome 5 is double and also gives a sum of 10. The two events may occur at the same time. Similarly, E2 and E3 are not mutually exclusive because outcome 1, 1 is a double and gives a sum of 2 and is less than 4. The two events E2 and E3 may occur at the same time. Similarly, E3 and E4 are not mutually exclusive. A sum can be less than 7 and less than 4 at the same time, like example 1 and 2. Now we jump into the formal definition of probability. We have already used this definition when we started our lecture, like total number of outcomes come in the numerator divided by sample space. Total number of favorable outcomes divided by total number of possible outcomes. That is what we have used the definition. I have started my lecture by explaining this definition. Means there are three boys, we want to select one, so total number of possibilities 3 out of 8 students, we are selecting one, so 8C1, which is 8. I have started my definition by explaining this one. Is that clear? Is that clear?
Yes. Is that NPR?
Yeah, this is, we are using here NCR. We
Oh,
are,
it's not N. It's not NPR. It's NCR.
yeah, NCR.
Oh, okay.
So we solve one example. If a card is drawn from an ordinary deck of 52 playing cards, find the probability that the card is red card. Now, how many red cards? There are 26 red cards. We are drawing one card and we are saying that that should be red. So the probability out of 26 we are drawing one, and we are drawing one card out of total 52C1. Is that clear? So it is 26 over 52. If you take NCR of 26C1, that is 26 over 52C1, that is 52. Like here you can see 26 over 52. Is that clear?
Yeah.
Yes.
The card is a diamond. Now, how many diamonds in the playing cards? There are 13 diamonds. We are selecting one diamond, so that one will come from these 13, and total are 52C1. So its probability is 13 over 52. 13 over 52. Is that clear?
Yes.
Yeah.
The third is the card is 10. The card is 10. There are 4 cards with number 10. So 4C1 over 52C1. So it is 4 over 52. 1 by 13. Is that clear?
Yeah.
Next is a fair coin is tossed 3 times. What is the probability that at least one head will appear? The sample space for this experiment, 3 head, we can say that we can get first 3 heads. Then we start from the tail, first 2 head and then tail. Then we move this tail in the middle. You can see it is here. Then we can move this tail in the first place. You can see it here. Now we start with the 2 tails and move the head. Head will come in the middle, then head will come in the first. Now the last option is we get all 3 tails. This is how we list down. This is a technique to list down all the possibilities when you toss 3 coins. Now the condition is that the question is, what is the probability you get at least one head? In all these options, we are getting at least one head except this one. So we list down all the possibilities, we are getting at least one head. These are 7 out of 8. So the probability is 7 over 8. Is that clear?
Yeah.
Okay.
Yeah.
So now there is another definition which is called law of complement. Sum of all the probabilities is equals to 100. Sum of all probability equals to 1 is equals to 1, like percentages. Understand? If I say 30% chances that you will fail the midterm, so what are the chances you will pass the midterm?
60,
Sorry?
60%.
No. If I'm saying there are 30% chances you will fail the midterm. What are the chances you will pass the midterm?
70,
70. How do you calculate this?
100, subtract 30.
Very good. Because we know
Subtract from
total
100.
total percentage is 100. So 70. Similarly, the total probability is 1. We are saying that at least one head. If we say that what is the probability no head appears, so we will subtract it from 1, total probability 7 by 8, so it would be 1 by 8. This is how we apply law of complement. This is called law of complement because we know that the total probability is 1, so we can subtract it from the total probability and we can get the answer. Is that clear?
No.
No, probability was 2. This is called law of complement. Any questions so far? Any questions so far? Now we solve these examples of if 2 fair dice are thrown, what is the probability of getting a double 6, a sum of 8 or more dots? A sum of 8 or more dots. Who can solve this? If 2 fair dice are thrown, what is the probability of getting a double 6? What is the probability of getting a double 6?
Sorry.
Huh?
What in this concept, what does fair dice mean?
Fair dice means that it is unbiased. It is not like that if you know that if you roll it in a certain direction you will get 6. If you know in advance, then
Wait,
yes. Yes.
can you say that again because it was disconnecting?
Okay. A fair die means that it should be an unbiased die. It does not like that. It should not be like that. If you know in advance that this die, I have rubbed it or I have scratched a certain way,
Yeah.
and now you know that if you roll it in a certain way, you will get a particular number. Then it is
Yeah.
not an unbiased die. You should not know.
Okay. Thank you.
You should not know what will you get in advance.
Yes.
So first example, we draw a sample space. We are rolling 2 dice, so we can write 1, 2, 3, 4, 5, 6. So here 1, 2, 3, 4, 5, 6. So you can list down all the possibilities. 1, 1, 1 2, 1 3, 1 4, 1 5, 1 6, 2 1, 2 2, 2 3, 2 4, 2 3, 2 4, 2 5, 2 6, 3 1, 3 2, 3 3, 3 4, 3 5, 3 6, 4 1, 4 2, 4 3, 4 4, 4 5, 4 6, 5 1, 5 2, 5 3, 5 4, 5 5, 5 6, 6 1, 6 2, 6 3, 6 4, 6 5, and 6 6. The question was getting a double six. In all these 36 options, how many times we are getting double six?
1.
1.
1 by 36. We are getting 1 times double six out of 36 possibilities. Sum of 8 or more dots. Sum of 8 or more dots. So we are getting sum of 8 from these numbers. If you see 6 plus 2, 8, 5 plus 3, 8, 4 plus 4, 8, 5 plus 3, 8, 6 plus 2, 8. Understand? These are the possibilities we are getting.
Yeah.
So it is 6 2, 5 3, 4 4, 3 5, 2 6. It says 6, it says 8 or more. More means it could be 9 as well. So 6 3 5 4, this one also counts. So it is, are you following? Is that clear?
Yes.
It could be 10 as well. So for 10, these options will be added as well. It could be 11. And it could be 12. So how many options we have? What is n of b? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15 times we can get some 8 or more. So the probability of b is n of b over n of s, sample space is 36. So 15 over 36. Is that clear? Is that
Yeah.
clear? Okay. So second example is 6 white balls and 4 black balls which are indistinguishable apart from the color are placed in a bag. If 6 balls are taken from the bag, find the probability of there being 3 white and 3 black. 6 white balls, 6 white, 4 black. We want to draw 6 balls. Find the probability that 3 are white and 3 are black. Understand? Hello,
Hi.
can you listen? Where did
It's lagging. It is lagging.
uh, Where did it disconnected? Please tell me what I was saying when it was disconnected. Nobody able to tell me.
Huh?
Where I was when it was disconnected.
You were writing the white balls and black balls.
Okay.
You were writing the numbers of
Okay.
the.
Okay. So in total, we are selecting 6 balls. So there are total 10 balls. Out of 10, we are selecting 6. So this is our sample space. Now we are selecting 3 white and 3 black. So N of E. Now 3 white will come from 6 white times, and 3 black will come from 4 black. So this is total number of favorable outcomes. So the probability is 6C3 times 4C3 over 10C6. We are selecting 6 balls out of 10. 3 are black and 3 are white. In total, you can see 3 plus 3, 6, 6 plus 4, 10. Did you get my point, what I'm explaining right now? Huh?
Yeah.
Is that clear? Is that clear?
Yeah.
So
Yep.
we can stop our lecture here, and this PPT, these 4 examples, 1, 2, 3, 4. There are 4 examples. Now listen it very carefully. What is your assignment? You will convert these 4 examples into 8 examples, and I will convert these 4 examples into let's say how 1, 2, 3, 4 into 12 examples. So in total we will have 20 examples. How will you convert them into 8 examples? For example, question number 1, if 2 fair dice are thrown, what is the probability of getting a double 6? First question here, it is saying getting a double 6. Understand? Double 6. You can change it, getting a double 5, getting a double 2, getting a number more than, getting a total more than 11, getting a total less than 6. In this way, you can convert them, you can convert one problem into many. Similarly here, if you see example 2, 6 white balls and 4 black balls. If 6 balls are taken from the bag, find the probability 3 being white and 3 being black. You can change it, find the probability that at least 2 are black. At least 2 are black, or you can say 2 black and 4 white. In this way, you can change the problems. Is that clear? Does it make sense to everybody?
Yes.
Okay.
How many
Similarly,
did you want us to do?
sorry?
How many did you want us to do?
Yeah, these are 4 examples. You will 1, 2, 3, 4. There are 4 questions. You will make them 8.
Yep. Okay.
I also I will make these 4 into 12, and I will send it in the group for your an assignment. In total, you will have 20 questions to solve.
Okay.
How about?
How?
Yes, Tiffany.
So we just relearn combination in a different way,
No, it is
like much simpler.
it is the same way. There is only one way, not a different way.
But you said we learned it.
What do you mean? I did not get your point.
Okay, never mind.
Okay. So, is that clear to everybody? If it
Yeah.
is clear, then see you on Wednesday.
Wednesday.
Yeah.
Yeah.
Okay.
Okay.
How was the
Thank
lecture?
you.
Please tell me honestly, like, is there any way I can improve it more?
It's just annoying with the disconnection sometimes, but that nobody can help, so it's
Yes,
fine.
exactly. Otherwise, tell me. Otherwise, tell me. Okay. Okay, see you then.
See you. Bye.
Bye-bye.
Bye.